the chapter is chapter 8, basic loops. Okay, basic loop. So based on our schedule, Unit 1, we are on the basic programming. It's up to string. This is Unit 1, okay, the elementary programming. It's just talking about data type and the basic object relationship. So this one actually pretty much support your coding bed level 1, okay, coding bed level 1. So at this moment, you need to catch up if you are not finished coding bed level 1 yet. And then after that, we working on to the level 2, actually Unit 2. Unit 2 is the program structure that including if then else, while loop, for loop, and functions. This called structured programming. And structured programming is up to chapter 10, up to chapter 10, okay? Up to chapter 10 is Unit 2. So Unit 2 roughly mapping to the coding bed. It's not the same, but roughly mapping to the coding bed level 2. Okay. And then after that, we go into the object array, 2D array, this part up to chapter 19, this portion from 11 to 19, these are basic data structures. 1D array list. And the 2D array. Okay, so these are basic data structure, very simple data structure. It's just probably 10%, 20% of the data structure. And the last 2 chapters are on basic algorithms. Okay, so these are the organization of the AP Concept A course. Okay. So right now we are going into the basic loop. Soon we will finish the level 2 soon, up to the lecture 10. Okay, today we are on basic loop. So that's about the AP Concept A course. Now let's look at the bigger picture of the programming. The bigger picture of the programming is, let's don't talk about this. Let's talk about this chart. This one is a course syllabus for my course at the Lewis University, the programming language courses. These are college senior course. Okay. It's doing the language translation of computer programs. But anyway, what I want to say is to learn computer science, this is the chart. I already posted in the group, but this is a chart you need to know, okay? Usually in US, nobody is giving you this chart. But what you need to know is that your AP CSA is somewhere here. This is AP CSA. AP CSP is right here, just about Python 1, AP CSP. Okay, and then you may learn some JavaScript, but JavaScript is not in the main problem-solving domain, it's software engineering. Okay, so you actually, in high school, we recommend you to at least know some problem-solving. So in high school, we recommend you to finish up to here. Okay, so if the high school don't give you the courses, you may want to take them in the community college. Okay, community college. And then computer science, there are 4 major branches. So one branch is core, CS, this is programming and problem solving. Another one is theory. Another one is hardware. Another one is software. These are 4 important core CS that we talk about. So usually in the college first 2 years or 3 years, you will learn these. to be major in computer science. So hardware, you learn logic design, how to design logic gate, computer organization and assembly language, microprocessor, what is a processor, and then parallel processing. Okay, these are hardware trade. Theory, you learn math, Boolean algebra, grammar and language theory. Okay, this is computing theory. And then software, you learn database, operation system, networking. Sorry. Embedded system. Okay, these are system software. So when you build a computer system, you need the hardware and software. So that's what you want to learn in college if you want to major in CS. But if you are a high school student, our recommendation for CS students is up to here. If you are not CS student, you are engineering student, maybe at least you need to learn APCSA and APCSP. Okay, if you are business major, maybe you just need the APCSP. So that really depends on what major you really go to, okay? But if you don't have the course that you can take from your college, then you can go to your nearby community college. So what I recommend for Bay Area student is the Foothill College. So they do provide CS1A for Java. So they do have a 1A, let me pull it down. 1B, 1C, okay, it's 1C. So 1A, B, C here is equivalent to what I say, the 1, 2, 3 for Java, okay? And then you may go for 2A, 2B, 2C. 2A, 2B, 2C is for 2A, 2B, 2C. These are C-level plus series, okay? Then there's another trend, you can go for 3A, 3B, 3C, okay, 3A, 3B, 3C are the courses for Python 1, 2, 3, okay? So basically, community college give you all the courses that you need. And then other courses in community college, like Foothill College, they'll give you data structure, data science, AA, computer organization, artificial intelligence, machine learning, discrete math, everything you want to have, JavaScript. So these community college courses will have many courses over here, everywhere. Okay, you can take. Up to you, okay? Then it's up to you to explore. Then go back to the activity part. So you as a high school student, you need to learn the 4 basic languages here. Then go into the problem solving, data structure to the user goal and lead code for interview. That's problem solving track. The other one is that you want to learn software. So you need to learn database, networking, parallel processing, AI, data science. Then you go into these different software projects. Okay, so these are the activities. So about the course and activities I post in the group, you can download them. Okay, these 2 charts that I posted here just give you the idea of what they are. Okay, anyway, we actually just remind you where you are right now and then what we are going to do. So we are in level 2 right now for coding bed. And if you are not up to coding level 2 yet, you have to catch up, okay? And then coding bed main purpose is that you need to practice the problem over and over again, making sure you know about the basic program structures, how to do finding some number, how to avoid numbers, how to pick up 2 numbers, every other numbers, how to actually finding the first number and the last letter and first letter and up that last letter and then do some operations. Okay, those kind of basic program idea, coding back would give you the idea of how to do it. That's the purpose of doing that. Okay, that's the purpose of doing that. And in our course, this lecture, it basically just teach you what is if the decision, what is the repetition, and what is a function that you want to call. But that's not enough. That's not enough to solve problem. On top of these different basic program language, you need to know about the program structure, the loop, the while loop, the for loop, how to use it in the most efficient way, and what are the functions that you can call. Okay, and then before that, if you have both of these, you know the language well, and you also know about the program structure well, then the next one you move on to do problem solving to solve proper problems. Then you need math and algorithm to solve it. Okay, so that's the plan we have. So at this moment, you still on the program structure, need to pay attention to these basic program structures and try to understand them. Okay, try to understand them. So today we are on the basic loops. Okay, so we will talk about what is while loop, what is a for loop, and then break labels, repetition loop, statistic loop, sentinel loop, token loop, menu selection loop, input validation loop, content loop, index loop, capitalization loop. Okay, these different loop. So first, let's look at the loop, while loop. Okay. Number one, the purpose of the loop is for repetition, repeating something. Okay. That's the first purpose. Remember, always open the parenthesis. You need to close it right away, just like what I'm doing. You open the curly brace, you must close it right away before you put something there, and then you open. Okay. So you may do this system out print line. Welcome to Java. Okay, you may do this. Now you may want to print it for 3 times, so you actually can copy it for 3 times. Okay, so you can copy as many copy as possible, but in fact, that's not efficient when your number of the line increase. So how about if you want to do 300 line, then you need to copy 300 times. So that's not efficient. Because that's not efficient, so we need to have a loop to repeat it. So to repeat it, we actually have a condition that you would check. This one, we call it continue condition. So there's a Boolean variable b. If b is true, b is met, you will continue. You will continue the loop. Okay. And then you will update the loop variable. So there's a certain thing that control your loop, that's called loop variable, and then you go back to check. So your loop variable need to have an initialization. Let's assume that it's actually I equals 0. Okay, and loop variable got updated when you do I increase. Okay, that's actually loop variable. So here you may have I less than 300. Then you will complete the loop. So they are continue condition, initial condition, and the update conditions you may have. Okay, that's a basic concept. But now, you do want to repeat this welcome to Java 300 times. So you may want to use a while loop. So you say while. So while if you put a true over there, is that okay? That's okay. True is okay because true is always true. That means you go into the loop is always true. And you do welcome to Java and then go back to check it, it's still true, and keep going, keep going, keep going, keep going, you will never get out. You will never get out because it's always true. So you keep going, and right here you can see that actually the blue bar is moving. So it actually not going to end. So you can click on the corner one, click, and you will stop it. Okay. So run one more time. It's still going. You can actually also use a tool, reset Java virtual machine, now reset your Java virtual machine and reset it, you stop. Okay. So that actually is the way you terminate a program that is keep running. Okay. So in this kind of loop, we call it infinite loop. That is a loop that will exit because your continue condition is true. It's always true. So when you get out the exit condition, when will you get out of the loop? The exit condition is not true. Here, your continue condition is A. When you get out of the while loop, then A will not be met. So if you get out to here, then not A will be true. Not A is false. So you will never get to here because it's always false. You will never get to here. So this one continue exit condition is not true. Okay, it's not true. So basically, this is a infinite loop. You will never get out. Okay. Now let me actually copy this one. So for loop design, you don't want to do that. Okay, you don't want to make your loop infinite loop. So let me have a repetition number 2. You must have something that you can terminate the loop. So one way is that how about we actually put a variable I less than 10. Then this is called loop variable. So we actually declare integer I equals 0. Okay. So I equals 0, and then your I less than 10, you will print it. So it is 0, and then you print it. It stay at the 0, it's still printed. It stay at the 0, it's still printed. So basically, this one still cannot get out of the loop. Still an infinite loop because you never update the loop variable, so it still cannot get out of the loop. Okay, so now you need to update your loop variable. So right here we do I increased. Okay. So now this continue condition become continue condition become I less than 10. So here the exit condition becomes I greater equals 10. So here, what I tell you, this one is A condition. A condition is equal to I less than 10. So A bar, not A condition, is your A exit condition will be I greater equals 10. So you will I equals 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When you reach 10, you get out of the loop. So you get out from here. So basically, I equals 0 to 9. Totally, you print out the line for 10 times. Okay, so this is repetition. Okay. What I want to say is remember this one is called continue condition, and then that's a condition. If the Boolean variable there right here is educated now, that's not a condition. Okay. And then you have a loop variable using I, that's called, we call it control variable or loop variable. That's your I is used to control the loop because you will continue condition based on it. So the design of the continue condition and the loop variable is the key idea when you design a loop. Okay, when you design a loop, you need to pay attention to these two things. That's more important. How you initialize, how you test it, and how you update the loop variable. And also when you will get out of the loop. Okay, these are the idea that you want to have. So this one will run you for 10 times. Okay, and then you do see program terminated. Okay. Any questions so far? This is a while loop. Now, sometime this one actually we can also call it counting loop because your I is counting. Now let's look at another one. How about if my number is starting from 20? If you start from 20, your starting line is right here. You're increasing this way, but your exit condition is less than 10. So you get this way, you still will not get out of the loop. So the exit condition sometimes still depending on your initial condition. Okay, you actually never get into the loop, and it automatically say terminated. So initial condition and the loop variable and the continue condition and exit condition is the key that you design your loop. How you want your loop work, that's very important. Okay. Now let's actually look at repetition 3. So we have an infinite loop that will never end. We have a definite loop. This one we call it definite loop. That will end. Okay, or we call it a counting loop. We count the variable. Now we may have another kind of a loop that actually is non-deterministic loop. This one we call it non-deterministic loop. That means that whether the loop will finish or not, we don't know. We don't know. Okay, let's look at this kind of the non-deterministic loop. So not using the I as the control variable, we use another things. So let's use import java.udil.star. So here we will have a scanner. Input equals new scanner system. We hook up the keyboard, and then we say system dot out dot print. Okay. Enter a word. Exit. Okay. Quit. Okay, we are expecting a word that actually is exit, then you will quit. Okay, so we will do this. We will do string word equals input that next line. Okay, if word that equals exit, we will quit. Okay, we will quit. So this one, if you continue, it's a not. Okay, so continue condition is word that equivalent equals exit is false. when word that equivalence is false, then you will continue. So when you get out right here, the exit condition will be word that equals exit is true. Okay. So you go into there, you actually print the welcome to Java, but you need to read in the word one more time in order to get the next try. Okay. So you have a question, you got an answer, evaluate the answer, and then you do print. And then you get a question again, and you got an answer again. And you do looping like here. This is called repeat loop. Okay, repeat. Read, evaluate, print, and loop. Okay, this read. This one is evaluate. This is printing. This one is loop back. Loop back is one more time. Okay, so this is called repeat loop. REPL loop. Okay. Okay, this one is wrong. Okay, so when you hit the exit, you quit. How many times you will go into the loop? I don't know, because there is nothing counting. So this kind of the loop, we call it non-deterministic loop. It really depends on your input. You input meeting the format, then you actually, it's okay. If your input doesn't meet the requirement, you will not quit. Okay, this is called repeat. So you go to the internet, and then you do repeat. So there is an online interpreter called repeat. REPLIT. Okay, then you can learn Python from here as well. There are some courses, and you can also do REPL Wikipedia. They'll tell you what is read, evaluate, print loop. Okay, these are the basic terminology. So these are very basic loop structures called repeat loop. Okay, so we actually teach you counting loop, and the second kind of loop is repeat loop. So this one right here, you can actually put another condition. You can do the two lower case. So if you put a two lowercase right here, your word maybe is exit, maybe is exit, maybe is exit, but they were all being converted to exit. So this one, adding this to lowercase, making this condition to check to be case insensitive. Okay, this will make loop case insensitive. Okay, all capital, it will still quit. Okay, so this one is called repeat loop, and we also make it case insensitive. Any questions so far? Any questions so far?
No.
We are talking about basic ideas. Okay, so these are the while loop. So while loop's basic motivation is you repeat something, okay, and then you can count how many times, okay. So you have the counter. So you may have a counter loop, and then keep counting, okay. That's one way you do it. So this one can teach you how to do it, okay. We'll do this sum and average later, okay. So next one is you may have a, let me see, you may have a, let's look at this sentinel loop. So in a way, this repeat loop is a sentinel loop. You may have a exit to quit, okay, exit to quit. So but sometimes you don't want to use exit to quit. Let's actually try different things. Okay, let's try a sum loop. Okay, you want to add sum. You want to sum up a few numbers, but you don't know how many you want to have. So that's an indefinite loop. So you keep enter your number until the number that you actually want to stop. Okay, you may want to enter a few number and take in the sum. So you may have an integer sum equal 0, okay? And then you will do actually integer, okay? A equals input but next int, okay? So here you may add system.out.print. You will say enter a number 0 to quit. So your continue condition is A not equal 0. Your exit condition will be A equal 0, you quit. Okay. So you read that number and then your sum will increase by A. And then you read that number one more time until you hit a 0. Okay. So this one still in a repeat structure, but we call it sentinel loop. We call it a sentinel loop. Sentinel is a guard. So the guard is 0. Okay. 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 So that you have a guard, but sometimes you would like the guard to be 999. That's also okay. That's up to you. Okay. You can determine which one is your sentinel, your guard. So let's change it to 999. So a condition that you will never use, the number you will never use, as long as you know which number it is fine. Okay, any questions so far? Any questions so far?
No.
No.
That's the sentinel loop, okay? So we actually, okay. And also, we also form something called sum loop. Sum loop, you actually enter a number and add it to sum. So basically, you keep asking a add it to sum, getting a add it to sum, getting a add it to sum. Okay, something like that. And at the end, you will have sum you can use. This is sum loop. Okay, we'll talk about this a different loop later. Now, next one, I will not jump into do while loop. Instead, I'm going to go to the for loop. I'm going to go to the for loop. Okay, from the representation tool, you have a counting loop like this, right? No. Number one. So this is a independent loop. You will never get out, okay? I'm sorry. You will never get out for this loop. You'll never get out. Okay, and you terminate it. So this is independent loop. But now this loop, if I comment out this one, and I do this, I do for semicolon, semicolon, true, do nothing, just this. Just do this. So you're supposed to have the initial condition here. You have continue condition here. You should have a update condition here, but I do nothing, nothing, nothing. Is nothing, nothing, nothing okay? Yes, nothing, nothing, nothing is okay. It's the same as your while true loop. The same. So this loop and this loop equivalent, the same. It's the same as you put a true over here. Is that okay? Is that okay? This loop and this loop are exactly the same. So here nothing, nothing is that okay? That's okay. Here even nothing, okay. Actually, none of the condition has anything still okay. If the middle one don't have the true, it will automatically be the true. That's the rule for Java language or C language as well. Any question?
No.
No. Okay. That's the this one for loop. Let's look at for loop number 2. I'm talking about is just to let you know that what is the language structure. Okay, you need to go back to the fundamental to know about what is a for loop. Not just for I equal 0, I equal 10, I less than 10, I increase. You don't do that every time. You have to depending on what you want to do. Okay. So if I actually do this, and then I put the integer I equals 0, and then I increase. This one is a forever loop, but let's change it to I less than 10. So we print out 10 times. So this loop is exactly the same as the repetition number 2. That for loop this for loop number 2 is the same as this. These two loops are the same. These two are exactly the same. So in a way, for loop is a specialized while loop. You have the initial condition being put over here, your update condition being put over here. Other than that, a for loop is exactly a while loop. That's what I want to say. Okay, so this is for loop number 2. Let's look at the for loop number 3. So for loop is a specialized while loop. 2 has 1-to-1 mapping. They are exactly the same. So you actually take this one, cut it here, put it over here. Take this one, cut it, put it over here. Then the two loops are the same. It's the same as the while loop. Okay, this is loop number 3. Any questions so far?
No.
So in a way, what you want to initialize, there's no limitation. What you want to actually be the continued condition, there's no limitation. What you want to update, there's no limitation. It's up to your programming need, okay? And if you don't want to put it, you want to delete it, it's okay. You want to do I increase by 2, that's up to you. No one say you must do what. Okay, that's the for loop. So for loop is a specialized while loop. That's what I want to say. Okay, so we finished the 2 basic loop. Next one, we are going to look into the third loop that's called do while loop. So do while loop is slightly different from a while loop and for loop. It is that you will do it at least once before you check the condition. Your while loop, you will check the condition first before you go into do something and then update and then redo it again. This is the while loop or for loop. Do while loop, you will do something for the first time, and then you will actually update it and do check-in and then repeat. This is called do while loop. Okay. So what usually used for do while loop is for the, let's do this. Okay, let's do this. Let's create do while loop. Okay, before you write it, you work out such a structure, okay? Now you have the scanner, so right here you can do this, you can put it as here, if you have an integer a, this integer a outside cannot use. So sometimes you want to declare this a outside, okay? And right here you read it again. So you enter a number and then you print it, and then you check if the number is an even number or not. If not, you will continue. So here, this one is your continue condition. So you read the number at least once. So this part would do at least once. While loop may not do once. While loop, you actually check right away. You may not go into the loop. But do while loop, you will go into there, do at least once. So this time you will read the number at least once. Okay, and then check the condition. And then you will get out here. So when you get out the exit condition, it's still the same. It's actually 8 modulo 2 equals 0. So actually this one, A is an even number. Okay, and then program terminated because your A is even number. Okay, so when you have an even number, your program will terminate. Any questions so far? This is do while loop. So these are 3 basic loops in computer science. We have one more that's for each loop. We will cover it later. So far, we are doing the traditional loop. Any questions so far?
No.
No. Okay, so these are the 3 different kind of loop. Next one, let's do a input validation loop, okay? So these are basic loop structure. You have the while loop, for loop, do while loop. Okay, these are basic loop structure. So let me put it together, kind of putting them together, okay? Okay, now, next one. Next one, we are going to do input validation loop. Input validation loop is very useful, especially when you do a ATM system, something that need to have the input, but your input may not be validated. Then you need to redo it again. So let's do this one. You may check for password, check for birthday, check for something, okay? Okay, let's assume that we do hook up the input. So you are going to ask for a person's age, right? You can do the repeat loop or you can do while loop. Let's do while loop, okay? So let's do while loop. Okay, let's assume this is a regular normal people. Normal people's age will not be negative, will not be more than 100. Let's assume that the person never live longer than 100 age, okay? Age of 100. Okay, but right here, one problem, this age is a local variable to the loop. So this integer only alive one iteration. So this age right here, it doesn't see it. So to solve that problem, you have to define your age over here. Okay. Then this age is okay. This is the first version we have. You can also write it as a repeat loop. So you do action for the age while is less than this number, and then you print it and then you execute. Okay, that's another way you can do it. So now let's look at it. Okay. Okay, this is input validation. Enter until you get a number. Okay. So right here, you may like to have another one that's here. It actually is okay. Any questions so far?
No.
So this is embedded loop number one. Okay. Input validation loop number one. Okay, let's look at loop input validation loop number two. But sometimes the person doesn't enter as you want. You go to an ATM to withdraw money, they want you to enter your password. But the user may not enter the password. He may enter his name. In that case, what will happen? your program will be broken because you have a type of mismatch. So this loop broke, but we want to guard against this kind of the problem, okay? So what should you do is that in case that this happen, then you will like to do this. You would like to, let me see, this one is number 2, right? Number 1, or number 1 is this. So number 2 got this. Okay, now, so what you should do is you want to use a try-catch structure. So here you do try here. Okay, if okay, you go to here. If not okay, you go to here. So there are 2 kind of error. One is input range error. Input range error, you will go to here. The H is still read correctly, but you go to here and you get out and come to here. Okay. And then if you are wrong format, you put in the wrong format. But right now you need to be careful. If you have a wrong format, then your age is still be 0. Then you will get out of loop to terminate the program. So that's not what you wanted. So your initial condition now you need to change it to -1 in order to make sure that the while loop will go back to read a new number. Okay, so that's what you need to know. So right here, let's try it again. Oh, you get a lot of wrong format. You never get out. Why is that? Why is that? Why you do new integer, but it actually keep going to the wrong format? You never go back to read it again. Let me try it one more time, okay? See anybody know what's going on? So I enter a computer science. But what happened is like, oh, wrong format, enter your age, wrong format, keep going. So they asked me for a new age, but I never had the chance to enter it. It keep pumping wrong input format. What's going on here? Anybody know?
Right.
Hmm?
Since the age is -1, it doesn't make the condition in the it does make the condition in the while loop true. So it does the code again.
Yeah, but suppose you should stop here to enter another number. So what happened is right here, this one is the input a new integer. So you enter computer science. Right? So what it happened is that you grab a computer that's wrong format. Wrong format, you come to the wrong format, you go back. So you still read the computer science, you still read the same number over again, you never get out. Here you have the enter mark, you will actually keep reading the enter mark, but still can't get out. So what you can do right here is that don't use this one. You actually do this, you actually do input the next line, and then you do integer the parse in. So you consume the enter mark. If you consume the enter mark, then the buffer's enter mark will be consumed. No matter what computer science you enter, you will read up to here and the whole thing will be read out and forget. If you don't do that, you have a computer science, but they are looking for an integer, but you don't have integer, then you are stuck there. You never get out of the sequence. Let's look at it one more time. Is that okay? Any question?
No.
See the difference between this version and previous version? Previous version, you ask for integer. You ask for integer, but your buffer had a computer science, so these are different words still in the buffer. They never got consumed. You want a next int. There's no next int in there. You just keep a string, and the string not consumed, you still go back to read it again, go back to read it again, go back to read it again, and you will never get out. So this is the right way to write a program. You actually consume the whole sentence, computer science up to here, the whole thing being read into the buffer. Forget it, forget it. Next time I want a new one. Okay, this is input validation program. Combine with try catch. Okay. Okay, so this one is input validation loop. Sometimes you need that, okay, when you do system programming. Let's see, let's look at more loops now. So next one, we are going to do using while loop to do sum, average, and maximum, minimum, okay? So we already finished this sum loop, okay? We finished this sum. Let's actually use this structure one more time. I don't want to type again, okay? Let's call it a maximum loop. So here, I'm not going to use a massive sum. I use a maximum. Okay, enter a number 0 to quit. This one, let's see. Okay, 0 to quit is fine. This is to find the maximum, okay? Okay? Any questions so far? So minimum is similar. Copy this one for min loop. Okay. Any questions so far?
No.
No. Now that's actually we have input validation, maximum, minimum, sum loop. Let's put a complete loop. Complete input loop. That's based on our input validation too. Let's assume that we want to take in a few number and then we want to check if the number is a we want to find the sum of all the numbers, okay? So here enter a number. Let me redo it. I'm going to redo it. Okay, I'm going to use a different way to do it, okay? Let me redo it. So here I may want to have a okay, now I want to enter a number and then would be exit to quit, okay? So it will be a string if it actually is an exit, okay? But it will be a number if you want to add it to the sum. So let's do that. Actually, let's do, and we want to have an input system like that, okay? So that's actually put the integer a equal 0 right here, okay? So I'm sorry, here let's actually do, let's do sum, okay, sum equal 0. So here I will have a string that's called word, okay, equals empty string. So while, no, this word should be equal to input at next line, okay? So while word dot to lowercase that equals exit. So here I give it a not. So if not equals exit, I'll continue to the loop. If yes, then here is exit condition. Word is exit. You quit the loop. Okay, so this is loop control. And then this input integer, let's put it on top. Okay, so you actually read to quit, and then you go into your system. So you copy this portion, you reread it one more time because it repeat structure. So you read the word one more time every time you go into there. Okay, so now you got a word. You got a word. If it's exit, then you get out, right? If it's not exit, you go into here. Okay, you go into here. So now next one, if it's not a exit, then we will do this. We will have a number. Let's call it integer a equals 0. Okay. Let's use a equals -1 as well. Okay, so here, here actually we will do this. We'll do a equals integer parse it of the word. Word will be translated to a integer. Okay, But this one, sometimes the format is incompatible, so you actually would do try. Okay. Okay, you try it. Let's see, this is not done. Okay, I'm sorry, I make a mistake. This one should be catch. Okay, and here, if you are not an integer, you come to here. Then you say the wrong input format. Okay. So right here, you pass it as an integer. If it passed, it is a number. Then what we will do is if a actually less than less than 0 or a greater than 100. Okay, then you do this. Okay. So now here we will invent another variable called Boolean done. Okay, equals true. So if the number is actually if a number is not in the range, we'll say not done. Not done, we'll go back to read it again, read it again, read it again, read it again, until you are done. Okay, you are done, or you actually you are done, or you actually go exit. Okay. Else part means the number is valid. Else part means the number is valid, and your sum or plus equals 8. Okay, so the valid number would be 80. Invalid number will look back to be a new one. Okay. No, this down should no. I'm sorry. No, this down is not necessary. Oh, it's okay. We don't need to have it down. This down can be taken out. It's just not 80. It's okay. We don't need to have that down variable. So if your number is out of range, it's just simply not 80. Okay. If it is actually a valid number, it will be 80 to the range, to the sum. Okay. And then when you get out, you say the sum or the valid numbers is. Okay, you see this input system now is more complicated than before, okay? So what happened is that if the number is not a number, it's actually a sum of the unwanted word. Unwanted word here, this try for integer will be wrong. You will go to here, wrong format. Wrong format, you read another string and then look back to here to check if it's exit. If not exit, you come into here, wrong format, you come to here and then pop back. If it is the right format, you come to the if statement. If the number is wrong out of range will not be 80. It will say out of range not 80, but you will still ask for a new number. If it is actually a valid number, then you will add to the sum. And then you will wait for the new number until you type exit. Okay, you see, this is the whole more complicated loop. Let's actually try to see if it works as predicted.
Dr. Chow,
Yes?
I need to go use the bathroom. I'll be right back.
Okay. So let's type in 10, 20, 30, and then -4, -5, and then exit. Let's see. The sum is 10, 20, 30, so you add up with 60. -4, -5 are not taken into. Okay, let's try another one. So here, let's see, let's do 10, 20, computer, -4, science, -10, 7, exit. Okay, let's look at this whole series. So the valid number are 10, 20, and 7. So the sum is 37. That's correct. Computer ignored, science ignored, -7 out of range, -4 out of range, -10 out of range. Is that okay?
Yeah.
So what I want to do is that I demonstrated a complicated loop development strategy, how you add a layer after a layer after a layer into a loop. So you maintain your logic correctly and also can present a complicated system. So this one now become a very, very solid input system. You can type in any of the string into your input system, and it will only pick up the number to add to the sum. The numbers that in the range will be added to the sum. Out of range will not be added to the sum. Non-numbers will be and non-exit will not be added to the sum, and wrong input format will be returned, and then exit will take out the system. Is that okay?
Yeah.
So that's what we want you to do to develop the while loop, not just knowing that let me do while loop, let me do for loop. That's basic. You need to, based on your understanding of what is for loop, what is while loop, what is continue condition, what is exit condition, what is try is catch, to combine a larger loop structure. Okay, a larger loop structure. That's what we want to do this chapter. Okay. So that's the more complicated input validation loop. The maximum loop, minimum loop, average loop, I think we know it. Okay, so we kind of doing okay there. Central loop we finished, do while loop we finished. It's a file processing, we'll look at it later, okay? Menu selection, we'll do it later. Input validation, we finish right now, okay? Lottery numbers. This is a project. Let me check what we want to cover, okay? For loop, we finished already. content loop we finished already. I just want to make sure we cover the basic loops so far. Index loop. Index loop. Okay, let's go to the index loop now. These are basic loop, okay? Just talking about what is a while loop, what is a for loop, what is this chapter only talking about basic loop. We have more advanced loop next week, okay? So this week we just touch you basic loops, making sure that you understand what is basic loop. So right here you may have an array, static integer array A equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Index loop is for integer I equals 0, I less than A the length, I increase. This we call it index loop. Given the fact that the loop variable is the index of an array. So every time you change the index, so you get that number. So that's as soon as you have a sum equal 0. And every time your sum will plus equal your A's, I's number, you add it to the sum. I think everyone knows this, okay? I just actually give you this example. Okay, so every time you use the index I equals 0, I equals 1, I equals 2, and then add it to the sum, okay, every time. This is called index loop. And next time we will look into more complicated index loop. This time we just go to the basic index loop. Now, another kind of loop is element loop. What is element loop? We actually is call for each loop. Okay, instead of for I equals 0, I less this, we do for each integer e in A. This one read as E is an element. I don't use I use E because it's an element in E. Okay, for each E in A, so your A, your sum, your total should plus equal E. So this E is an element, it's not an index. So basically, it's directly getting the 1, 2, 3, 4. It's not 0, 1, 2, 3. 0, 1, 2, 3 is the index. So you need to say A's, I's value. Here, E is not an index. E is the element. So we call for each E element in A array. We do this. Okay, that's called for each loop. Okay, it's called for each loop, for each element. Any questions so far?
No.
No.
So we cover the index loop and for each loop, for each element. So when you do Python, it's actually for I I in range length of A. This one I is an index, but it really is for each element I. Is actually an element I in the range function output. Range function output is a tuple of 0, 1, 2 up to the length minus 1. So it really is for each loop. It's not for index loop. Okay. Python don't have any of the four. Python don't have this loop. Python only have this loop. And Python here, this one is in. Here is using colon. Okay, that's the main difference. You have to remember that, okay? That's one thing you need to remember. And who can be put over here? Any of the iterable things. What is iterable thing? Iterable thing means array is iterable. Array list is iterable. Anything that you can count one by one. Set is iterable. Okay, those kind of things you can traverse one by one. That's called iterable. Okay. Commonly sees way of doing it is just do for each character. Okay, let's do for each character loop. If I want to get each character printed. So let's assume I have a static string alpha equals A, B, C, D, E, F, G. Okay, let's do this. So here I would say for each character ch in alpha, that's not okay. String is not iterable. String is immutable, it's not iterable. So right here, I'm going to do string don't have this. So you cannot do. So you this one you have to do to char array. You convert a string to a character array. Then it's an array, and then you can do system.out.print line. Each character can be printed out in this way. But for each character. Any questions so far?
No.
No? Okay, so we cover this for each loop as well. Right here, we cover the basic loops. Okay, so today we cover each of the basic loop. What else we want to cover? Let's actually look into the slices. Comparison should be fine. This one, let's look into this one. Double loop. Okay, let's look into the double loop. Let's assume that we want to type the sine cosine. We want to make this sine cosine value. Okay. So there's a step size. The whole circle is 2 pi. We want to print out the whole 2 pi's every value. Let's actually use every 10 degree to print a value. Okay, every 10 degree to print a value. So totally you are 360. You would divide the whole thing into 12 I mean 36 elements. Okay, let's do it. That's the double loop, okay? Double loop using double value to do iteration. Using double variable to control, okay? Okay, so the loop body, you use a value of the double value. This one, let's do work on something called x. Okay, x given 0, 0.0. Okay, x will less than equal to 2.0. Okay, x increase by. Okay, you will have from 0 to 2.0 every 10 degree you want to print the value. So basically this is actually totally 36 steps. Okay, so you will actually do 2.0 divided by 36. Okay, not many steps. You got the x and you would use the x to calculate the sines and cosines. So you do double sine equals that's the sine of your x that's the pi from 0 to 2 pi, right? 0 to 2 pi. So x is 0 to 2. Every time increase by one, actually 2.0 divided by 36. Okay. That's your sine. And you also calculate the cosine. Okay, you got these two, and you are going to ready to print the table. So you do system out print F. Okay, so it's actually single then percentage 0.2 F pi. Okay, find pi. Then your sine value. Sine value. Given your x and your sine and your cosine. Okay, so that's using double value to form a loop. So sometimes the loop variable can be a double value, okay? Here the last one doesn't show up because exactly, so here let's do this, okay? because we want to guarantee that 2.0 will show up. This is a floating point error, so let's do 1e minus 8, okay? Okay? Given that tiny error, your last one, 2.0, will show up. It's okay, because this is 2.0, sometimes it's 1.99999, but you actually is less than equal to, you don't get it, okay? Sometimes you don't get it. Is that okay? Just add the small, tiny buffer. You allow the boundary case to must show up. This is when you do the technique, when you do the double value to do loop control. Any question?
No.
Okay, this is how to generate this. Wait, I quit it again. So this is to do the double value, okay? This is a sine, cosine function. Reading data on file and this menu, we will skip it, okay? We'll skip it because these are too complicated. You can look at it. The counting word, the problem, we will do it later, okay? When we introduce the array, we'll do it later. Not now. Right now, you don't have a concept of array and histogram yet. Okay, any questions so far?
No.
No, if no, that's it for today. Okay, next time we'll go to the loop processing, advanced loop. Okay, advanced loop will teach you more difficult loop data, more complicated loop. Okay, today we only cover the basic loop. Make sure you understand what is the basic features of the loop, because that's when you build your own loop, you need to have the very detailed understanding of what loop should be used at what condition. So it's not just remember for each loop for integer I equal 0 and then I increase, not always like that. You have to design a loop for your best use of all of the conditions that you have, including your initial condition, continue condition, exit condition, and the update condition. These in combined will matter, okay? And sometimes your loop may be more complicated. You build your first level loop to handle the exit. Then internally, you have to design how to raise exception and how you actually handle the long outer range, and making sure when you look back, you can still read integers. Okay, that's when you do loop, you have to pay attention to those details. Okay, that's it for today. Good night then, and see you next time. No problem. Okay, see you. Bye bye.
Thank you.
Thank you.
Bye.
Bye-bye.
Thank you.
Bye.